Okay, we're learning about continuity at a point. Now these are kind of typical test questions here. This says find a constant a to make the following functions. That's been cut off there, but it says functions continuous at the real number line, on the real number line. I can't even read. Anyway, we're going to look at this one here. This is a f of x. It's a piecewise function, x cubed, where x is less than or equal to 2, and a times x squared, where x is greater than 2. And we're going to find a so that we can make this continuous. Okay, so that's the idea. We want to find a so we can make this continuous and at x equals 2. Alright, so the first thing I'm going to do here is I'm going to plug 2 directly into the function. Now we're going to be using this top one up here because this says x is less than or equal to 2. And equals means we're using actually 2's in the domain of this function here. So you take 2, plug it directly in, 2 cubed is 8. Now we want to take the limit, that'd be the next thing, and we're coming in from the left and coming in from the right. So coming in from the left, we're going to be using this top part because this says x is less than or equal to 2, and we do the direct substitution, and of course we get 2 cubed is 8. Then we're going to come in from the right hand side, so we'll be using the bottom one down here because this says x is greater than 2, and so here's our function here, ax squared. So we take 2, do the direct substitution, plug 2 directly in, and we end up with a times 4, right? 2 squared is 4, a times 4. Now remember, coming in from the left and coming in from the right hand side, if both of these are equal, then we could say that the limit exists as x approaches 2. So the obvious thing here then, what we're going to do is we're going to set the 8 equal to a 4 and then just solve for a. So we do that, we set them both equal, we solve for a, and we get a is equal to 2. Therefore we could write it out now that f of x is equal to, this is our piecewise function, x cubed is x is less than or equal to 2, and 2x squared. So for that a here, we go ahead and put our 2 in at x is greater than 2. So this is now a continuous function at x equals 2. Now x cubed is a polynomial and it's continuous on the entire real number line, so that was nothing to worry about. And 2x squared is also a polynomial, or ax squared, where a is a real number. It's also a polynomial and it's continuous everywhere, or I should say everywhere continuous. It's the proper way to say that. But we were concerned about it too. I want to look at what happens if a were some different numbers. What about if a were 3 and we plugged a 3 in right here? Okay, well if a were 3, this is what our graph would look like. Now you see that it's broken. See, we're trying to join this graph here with this graph. We're trying to join it. And if a were 3, well, this would be bumped up, right? When you would take 2 and plug it into our function, 2 cubed would end up being 8. And somewhere across here is about 8, lines up with 8. What if a were 1? Well, that would just be x squared, right? 1 times x squared, just x squared. So this is what happens to our graph here. It gets bumped down. You see this? It gets bumped down. So we need to find this a, which we found out to be 2, right? Would take this and move this up to where then they're both joined. And of course we can see that right here. This is the graph. It's been zoomed out a little bit, but as you can see here, this part of the graph here is x cubed, and then when we get to 2 right here, this part of the graph here is the 2x squared. Now it kind of looks like there's a hole in the graph right here, but there's actually not. I don't know why that's not nice smooth continuous piece right there, but anyway, but this is continuous at x equals 2.